Now that we have identified two similar triangles, let's see if the process is different for other types of shapes. So looking at these two shapes, Diana makes two sizes of earrings. Explain whether the shapes of the earrings are proportional, or in other words, are similar. So what is the first thing we do? Well, we must identify the corresponding sides with our symbols. So it looks like they're facing the same direction. This side goes up to the right, very similar to the way this side goes. This side goes a little bit lower to the right as it increases. And then these two sides seem parallel like they do here. So I'm just doing a quick visual check that they are facing the exact same direction. So now I can match the sides pretty quickly. So 10 matches with 6. 18 matches with 10.8. 9 matches with 15. And the 10 millimeters matches with the 6 millimeters. So notice how my symbols change, my colors change, but I have identified all of the sides. So now that we have done that, what is the next step? Well, we must identify the scale factor by dividing the new dimension over the original dimension. So new over original. So I can pick any pair of sides, and I don't really want to pick the one with the decimal. 10 and 6 look good, so I know that this is the new shape and this is the original shape. Oh, I've also forgot, what do we notice is going on between the original and the new? It is slightly getting smaller, so we call this a reduction. So that's keeping it in our head that we know that our fraction, our ratio, should be something that produces smaller numbers, just keeping it in mind. So the new dimension is 6 and the original is 10. So can I simplify this fraction? Yes, I can. I can simplify it by 2, and I get 3/5. So the scale factor is 3/5. I could also write it as a decimal and see that it is 0.6. So now that we have found the scale factor, we need to determine, are the rest of the sides proportional? And so the way we're going to do that is setting up our table. In fact, let me put it up here so I have more space. Original. We multiply by the scale factor by 0.6. And we get the new dimension. We could also multiply by 3/5, whatever your preference is. I prefer decimals. So I'm going to put all of the original dimensions I see here, 10, 10, 15, and 18. And we're going to multiply them by 0.6 to get the new dimension to test it out and see if we are truly proportional. And so 10 times 0.6, just going over here to show my multiplication. I have one number behind the decimal point and one number behind the decimal point here is 6, which means this is also 6. And now we can move to 15 times 0.6, 39, one number, so that is 9. And then the last one, 18 times 0.6, 48, 10, one number, I get 10.8. So let's go back and double check that we have matching pairs in our problem. I see 10 and 6. I see 10 and 6 again are matching. 15 and 9 match, and 18 and 10.8 match. So we can now answer our sentence. Are these shapes similar? Yes, they are similar because there is a scale factor. Because the scale factor is 3/5 or 0.6, whatever our preference is. And because they are proportional, these shapes, these parallelograms, are called similar. We're going to try some more on our own.